Hi there. I've recently published a set of scripts that can be used to perform physical I/O benchmarks on an Oracle database. And in this video, I just want to give you a quick overview of how to make use of these benchmark scripts. You can find more information on my blog, where I've published a corresponding note which describes some more details of these benchmark scripts, and you can download them from my GitHub repository. I've prepared a corresponding zip archive that contains already all the required files. So the most straightforward and easiest way to make use of this is just to download this zip archive, and the intended use is actually to extract and transfer these files directly to the database server where you want to run the benchmark on, but it's also possible to run them, of course, from a remote client, so you don't necessarily have to transfer them to your database server. So once you have extracted them, and then basically here you go, you have all these scripts that are required to run the benchmark, and this benchmark basically consists of 4 similar sets of scripts, and each set basically covers a specific I/O pattern. So we have physical single block reads, we have physical multi-block reads, physical single block writes, and physical multi-block writes. And in case of the physical read benchmarks, you can even specify the specific mode that should be used, which in this case is then either synchronous or asynchronous single block or multi-block I/O. So this is something that might be unique to this kind of benchmarks, that you can specify exactly what kind of I/O mode should be used for these physical reads, of course, provided that your platform configuration, file system, etc. actually supports asynchronous I/O, but most platforms and configurations nowadays should support asynchronous I/O, or at least it's highly recommended because it can make a tremendous difference in terms of I/O performance. And this is also exactly what you can find out using these benchmarks by running them in synchronous or in asynchronous mode. So there are basically 2 ways how you can make use of these benchmarks scripts. One way is using the so-called interactive scripts, because as you can see, each set consists of 3 scripts in total. There's one called interactive, which is one that you are supposed to run as sysdba, because it drops and recreates a suitable user for running the benchmark, and also grants on some sys objects like dbms log and dbms system. And this is one way how you can run this benchmark, by connecting a sysdba and launching the script, which will then provide you some details and introduction, and ask you some questions that will be used as parameters then for running the actual benchmark script. This is the second way how you can use this benchmark, by directly launching this harness script, which is the actual benchmark, which then does some preparation steps, creating objects if required, and so on, generating 8.wr snapshots, and then launches the actual benchmark activity, which is called something slave actual benchmark activity, as many times as desired and specified as a parameter. So assuming this is here my local database server running on Windows, I can go to this directory here, connect as sysdba to my database, and then launch this interactive version here, in this case for this single block physical I/O, which will give me this introduction at giving you some details what this is about, that it will drop and recreate a user that is supposed to run as sysdba, that it can make use of AWR functionality, so you should have a proper license. Also explains these two different modes, the synchronous and asynchronous I/O mode, and also gives you some ideas about object sizing, because of course you for those benchmarks that make use of the buffer cache, you probably, in order to maximize physical I/O, you want the objects created to be larger than your buffer cache. Otherwise, you might end up with running more logical I/O than physical I/O, which is in principle also a use case for these scripts, basically maxing out your CPU than rather maxing out your physical I/O. But the intended use, the reason why I've written these benchmark scripts is to maximize physical I/O. So for those tests that use the buffer cache, you have to take care that the buffer cache is smaller than the objects created. Basically, you end then up with two options. Either you make your buffer cache smaller or create bigger objects. So you can specify a storage clause so that you, if you want to set up a smaller keep or recycle cache instead of resizing your default cache, this option is also available and explained here. Or you go the other way, for example, in case you suspect also maybe some caching effects on lower layers like a SAN cache, you can create large to very large objects here, and in that case you can even make use of the parallel execution option if you are on Enterprise Edition. The scripts are supposed to cope with all kinds of configurations, so be it single instance or rack, be it standard edition, enterprise edition, Windows or Unix, Linux, Exadata, non-Exadata, PDB or non-PDB in 12c. The script is supposed to cope with all kind of configurations that you can think of, but since it's an initial release, you will appreciate that very likely it won't actually work flawlessly in all kinds of configurations. So if you find some problems, then please let me know, so I might have the chance to fix this and publish new version that then really works as intended. So the first thing that you will do here in this interactive part is specifying the user to drop and recreate. So you have to be careful at this stage, because the script will then drop this user that you have specified. And if you wanted to clean up, you would be done here and could stop the script by just hitting Ctrl+C. If you want to continue, go ahead. You have to specify a password that will be used to establish then these new connections, these new sessions that will run in parallel. Then you get an overview of your buffer cache sizing and the table spaces available, at least for those tests that rely on a buffer cache. You get this sizing shown, and in order to determine the actual space required, you have to specify a number of parameters. One of the most important ones is, of course, how many parallel processes you wanted to launch, because each of these processes will work on its own copy of data. So in this case here, I will specify, instead of the default of 8, just launching 4 of them. And then you basically specify the size. And the size in this case means per object. And for each process that you start, for this kind of test, there will be 2 objects, a table and index of similar size, as specified. So if I accept this 8,000 blocks default size, this means I will end up with one table with 8,000 blocks and one index with approximately 8,000 blocks. And since we have specified 4 processes should be started concurrently, and each will get its own copy. It's basically 8,000 times 2, which is 16,000, times 4 is 64,000, which is the number of blocks that these objects here will allocate. So you can now use this overview here to see which of these table spaces have suitable available free space or suitable maximum size, or maybe you also want to create a separate table space for this benchmark purpose, maybe with some specific properties in terms of performance, storage, usage, whatever. At present, the script supports only a single table space that you can specify, so we'll go for this test 8K here now. And then we come to the point about object sizes versus buffer cache sizes. So in this case here, you get an information, since this also shows you the block size of these table spaces. Since we have now chosen the table space, it will tell us that these 64,000 blocks at 8 kilobyte block size will allocate approximately 500 megabytes in this table space. So, and comparing this to the buffer cache size, in my case here, the default buffer cache, and since this is the default block size 8K, I would use default buffer cache is much larger, so this would then now end up here with logical I/O instead of physical I/O. So since I have set up a recycle cache here, I can make use of this and specify here recycle, and the corresponding storage clause will then be used when the objects get created. So in this case, I end up with a much smaller buffer cache than my 500 megabyte objects. Yeah, some of the object creation and codes will potentially make use of temporary table space. Therefore, we have to specify for the user that gets created also a valid temporary table space. And then we come to the point where we define the runtime of the benchmark, and the default is 10 minutes, which probably makes sense to have some time for warming up and then run the benchmark for a significant amount of time. You should at least run the benchmark for 120 seconds if you want to see the final query that gives you the IOPS or throughput rate result to show something meaningful, because it is based on $$ sysmetric history, which has a granularity of 60 seconds. So to cover at least 160 seconds in interval, you have to run it at least for 120 seconds. But typically, it probably makes sense to run the benchmark for longer. If you run it for a shorter duration, whether that makes sense is a different question. You would have to resort to the performance report created to see something about the I/O figures, because this final query will not show any rows. So let's specify some runtime. Then in this particular case, you have to specify this asynchronous or synchronous mode. So in this case, we go for the default asynchronous. Then if you run it, wanted to connect to a remote database, you have to specify here a connection string, which could also be an easy connect string if available and configured in your SQLnet, or allowed to be used. This should also work instead of a TNS names alias or whatever connection string naming method you want to use. Then you can specify here the parallel degree if you are running on Enterprise Edition and intend to create very large objects. This might speed up the object creation, so you can make use of parallel execution here and define a degree greater 1, which I won't do here. And if you run this from a remote client and not directly on your database server, this script needs to know what operating system the script here on the remote client is running, because it then makes use of either the start or no-hub command to launch these concurrent processes these concurrent sessions that run the actual benchmark. So if you run it directly on the database, that's fine, because it will be derived from $v version, the operating system. But if it's a remote, then you would have to specify if this remote client here is running Windows or Unix. So they would have to specify one of these things, because I'm running here locally on my Windows database server, this is just fine to accept the default. And now we can specify if we want to get a performance report generated for the benchmark run. By default, again, it will be derived from the edition of your database. If it detects an enterprise edition, it will create an AWR report. If it detects a standard edition, it will attempt to create a StatSpec report. But if you want to have full control here, you can specify which kind of report, or maybe even no report at all. If you specify none, no report will be created at all. So accepting the default here, it should create an AWR report because we are running Enterprise Edition. Before doing anything, you will get a summary of the things that you have just entered. So you can check here if that is fine with you. And then if you go ahead now at this point, the user will be created and privileges will be granted, and final step is then basically connect as this new user and launch the actual benchmark script with these parameters that you have just specified. So that is what will happen next. And the actual benchmark script now starts with the preparation steps. In this case, create these 4 copies of these tables and indexes, then launch the actual benchmark activity as many times as you have specified, and then wait the specified runtime duration. And before it then does this, it does some more steps that I can show you quickly, because it will of course then also create, in this case, an AWR snapshot. And in addition, you get also a copy from 12c on of this $v event histogram micro table, which can be used to get a histogram of the latency for these single block reads, in this case for the synchronous single block reads, because it doesn't make a lot of sense to do this for the asynchronous reads. It's only shown for the synchronous reads. And you can then use a corresponding query that is shown in the script header of the actual benchmark script. You can use a corresponding query to then get information about the latency distribution, which can be very useful to see whether you have outliers or maybe some uneven distribution depending on maybe caching effects and other things. So this is some bonus information. These 2 tables will remain after the benchmark in this schemas. So you can check the results using this query when the benchmark is completed, whereas the other objects that have been created for the benchmark run will be dropped afterwards. Once the duration has been reached and the benchmark should stop, these clients here are supposed to shut down gracefully once this runtime is over. But depending on how long it takes to run these loops here, to run these, in this case it's a simple nested loop join, a carefully crafted nested loop join that makes either use of synchronous or asynchronous I/O, and also the data is created in a way that it should jump to a different block for each row that it selects. So once this is done here, and this has not managed to shut down gracefully, you will see here that the script then attempts to cancel or kill these sessions so that they are no longer running. And the final steps are then, in principle, create another snapshot of this $v event history micro, create another AWR snapshot if you requested a corresponding report, or a StatSpec snapshot, and then create a corresponding AWR report and launch it. So and then drop the objects and show the final result, which is in this case the read IOPS rate achieved, which should be rather similar to what you see in the AWR report. These are two different sources in this case, but they come to pretty much the same result. And if you run the benchmark for several minutes, then you will have here multiple rows that match here in this $V symmetric history for these 60 seconds intervals covered. So you will end up with multiple matches here, and then this minimum, maximum, average, median calculation makes more sense than for this single matching row, in this case here for this short duration of the benchmark. So that is basically the way you can do this in this interactive way, connecting a sysdba, then specifying the user to create, answering the questions about the parameters, checking with the object sizes and buffer cache size. So that is one way how you can make use. If you want to make use of this in a more automated way, or if you already have a suitable user set up, you can also connect directly to this user. Don't make use of sysdba for running this test. I don't recommend doing it. Haven't tested it because the sys user, the sysdba, behaves in many ways differently. So I wouldn't recommend running these benchmarks as sys or as sysdba, but use a separate dedicated user. If you have one already available that you can make use of, so you can directly connect here to this user, and then you will find in the benchmark script header instructions how you can specify these parameters, what are the default values, and you also get in your example, an example how you would start this directly rather than using this interactive script. And basically this is what the interactive script then will specify when calling the script. So again, this would mean here run 4 parallel processes. In this case, use the synchronous mode. This would be the other option, using the asynchronous mode. You specify again the object size, 8,000 blocks per table and index, which will then, in this case, would end up with the same 500 megabytes for the text, 64,000 blocks, and the table space specification, optional storage, buffer cache specification, the runtime in seconds. In this case here, I would also have to specify this connect string. I would also have to specify the user and name and password. And in addition, you could also specify here again operating system, parallel degree, the StatsPack AWR report to create, and so on and so on. I leave this all as default. And when I start this here now, I basically come to the same point where this other script then launched, this benchmark script, creating the objects, launching the slaves, and so on. And you get then this final result.